Today, I'm going to talk about a bit about application migration and modernization, especially with some focus on containers and Kubernetes. So this is a very big subject. I could not cover a lot of stuff here, but I'm trying to make it a little bit on the higher level. So I'll try to talk about some aspects of the cloud, and ultimately we'll talk about what it means by lifting and shifting applications from on-premises to cloud and modernizing them. So a little bit around cloud. The cloud is fundamentally changing the way people do things and how enterprises are procuring and using technology. And by moving to cloud, enterprises can provision and consume resources as they needed it. So why organizations do this again? So cloud computing is becoming the standard and it's a new normal, and technology is omnipresent and it is changing the way we do things. And capitalizing on this shift is essential for organizations for innovation and growth. So when we talk about on-premises versus cloud, there are some fundamental differences in the characteristics of deployment and operations. So when you are on the on-premises, you pretty much have a fixed set of assets that we actually provision for different applications to use. But there are some 5 different essential characteristics of the cloud that differentiates from on-premises. So I would qualify them as on-demand self-service. So basically, the customers are able to do their provisioning as soon as they need it, as and when they need it. And so it's an automated self-service model. And then the second one would be a broad network access. If when you are on premises, you will have to wire up network for different environments or different scenarios. But when in the cloud, there is a variety of network access available. It can be easily connected to different devices and different networks and things like that. And then I would say the third part of that is the resource pooling. Cloud provides the shared resources and it's a multi-tenant environment. So obviously pooling means isolation. Proper isolation is required between tenants and so that we don't see each other. So that's one of the paramount important things that the cloud provider has to take care. And then the fourth one I would say is rapid elasticity. Basically, when you are on premises, you have a fixed set of assets. When you are growing your business and when new customers, new consumers are coming to your system, then elasticity is a big thing, right? So cloud provides native processes and automated provisioning for rapid growth based on load characteristics, and that's one of the greatest properties of cloud that we can leverage on. And the last but not least is the measured services, right? When you are on premises, everything is yours. You only care about the capital expenditure, and then when you are in a cloud, you obviously care about the services that you are buying and you are paying for. So there is a requirement for very granular set of billing and pretty much micro billing that is required, and then auditing of that is required, and then you should have proper transparency into all that. That's actually pretty much sorry, it's overlapping with my. Okay, so you guys are okay now? All right. There are too many windows. Yeah, I'm good. Yeah, I'm good. So okay, so let's talk about why is it okay, it's just a little bit overlapping with the other screen. Okay, now it's good. All right, so let's talk about some of the modernization goals. So when we talk about modernization goals, some of these things are specifically around business goals. Digital transformation is a big thing these days, and then you could talk about regulatory as one of these business goals, or growth and impact on business, all kinds of things like that. And these actually in turn drive some of the technical drivers. And we could talk about motivations around these movements. For example, some of those could be an executive mandate, and there could be something like a data center exit, like you have a capital expenditure and you want to get rid of that and then use more like a service oriented model. and there could be a business opportunity for a merger and acquisition. So we have two different companies and they are merging, and then you wanted to have interoperability between these two organizations, and then you could do a cloud orchestrated interoperability between these two organizations. Those kind of things are possible. And then from the technical point of view, we could have agility, other tech capabilities, new skill sets, and all kinds of tools that cloud comes along with that. And so there are some other, apart from all these things, there could be some other drivers such as the need of the hour. Like, for example, like some of the ad hoc requirements that you may have. For example, you have some database servers that are expiring, the license is going away, and then you need to have new servers for that. And then, building a whole set of servers on premises is again problematic. You need more of time or testing, all sorts of things. So you could actually use a service-oriented model from cloud, quickly move out to cloud, and then take this database and put it in the cloud and then use that. So there are some other scenarios like that. I wouldn't go too much into that. And then let's move on to the next slide here. Again, this is again how a cloud data center will look like. So when you talk about Azure, we have several regions, and then we have availability in so many regions, and each region is comprised of multiple data centers, and so that's how we provide you the redundancy and high availability for you guys. Underneath everything, you have the physical infrastructure, and we carve out the infrastructure of services on top of that and provide to you the customer. And primarily, we have compute services, storage services, and networking services. So the compute obviously has virtual machines and containers and all that. Storage can range from blob storage to disks and several things like that. So, and on top of that, we have the PaaS services or the platform services. The platform services actually take away the responsibility of managing the infrastructure from the customer. So basically, when you are doing infrastructure services, you pretty much have to taken care of the servers. But when you're in the platform services, you have your your responsibility is pretty much on the deployment of the application, management of the application, and versioning, bug fixing, all kinds of things. This is like the progression of environments from on-premises to a SaaS product. A SaaS product is pretty much, you don't really care about the infrastructure or the application, but you only care about provisioning. So Office 365 is an example of that. You don't really even manage. So there are some different approaches that when we take into modernization. SaaS is one of them, which is, we call it replacement. So here it is. First of all, the basic thing that you can do is rehosting. This means pure lift and shift. Obviously, virtual machines are running applications on your on-premises. You want to take that and put it into an Azure virtual machine. And there are some wirings to be done, but obviously this is the least, this is the easiest way to do, most effortless thing to do. But it is awesome. I mean, whatever problems that you have on premises, you are inheriting into Azure, but you have a hosting mechanism that is different. And the second thing could be a replatforming, where you actually take the application and change some of those infrastructure services into PaaS services, which actually takes care of some of the operational aspects of your application. You don't have to really, to care and mend your application infrastructure in that scenario. For example, moving away from a database server to a database service. Refactoring is the third option, where you actually tear apart the system and take the code, refactor it to suit the capabilities that the cloud provides. So that's kind of the third model. And the rewriting is totally greenfield. You just repeat a part and then make sure that you rewrite it. And again, gone are the days when we rewrite the whole thing in bulk. We usually do a piecemeal type replacement. So when you are, let's say you have a car and you wanted to replace so many things out of it, you can replace one at a time. and then test that and run it, and then ultimately you replace everything. And people ask this philosophical question: if you replace everything of something, is the same thing, right? So ultimately, it is going to be better than what you have, and then you should be able to have a whole new system that actually runs better than what you have. So now let's look at some of the benefits and challenges. I think this is self-explanatory. You can actually rehost and replatform or refactor and ultimately rewrite. And the last piece that you don't show here is the retire or even replace, which is the SaaS kind of solution. So each needs different mindset. Usually people mature from rehost to rewrite. Sometimes with the if there is a time commitment, then you actually rehost it and then slowly optimize it. So there are some of those. So this actually provides you some sort of, actually there is a Microsoft documentation on this as well, but I'm not going to go too much into this. Basically, you have forking from the first decision point where whether you have migrating or innovating or a building new one, and depending on your platform and your special situation, you will pick up one of these things at the, and this is not, and there is a difference between application migration versus the platform of choice. So the previous slide, what I was talking about is how you are re-engineering your application. The second one is the deployment choice. Like the first one is all about what do you call it, like either your code and your application as such. The second one is all about the hosting model. So deployment model versus architecture of the application. So there are two different things here, but in this scenario we are talking about a lift and shift decision flow, where you are actually taking and then putting an application into a container as it is, but there are different choices for you. And so there is virtual machines, there is hosted app services or containers and all sorts of things like that. So that's something to be aware of. Now, so when you are looking at a traditional n-tier application, you may be familiar with the MVC paradigm, model view controller. You have a model which is your data set, and then your view is your presentation layer, and your controller is your business logic that actually takes the data out of the model and then does business processing on that. And all these things, ideally, all these things should be independent of each other. Just like changing the model should not affect your process, or maybe, but then eventually, at least the web tier should not be affected by the data tier. So it's almost like changing the engine of a car should not change your tire or something like that. So it should be modularized. So things like that. So this is the n-tier model, and then people often confuse the microservices versus containers. Microservices is an application design philosophy or architecture model, where you are giving changing away from a monolithic approach to a tiered approach or a service oriented model, where each of these services are the integration of all these things is your application. Basically, sum of all the parts is your application. So each service has its own independent function, and you add up all these things is your application instead of like everything in a bundle. So these things are independently scalable, so that and you can also control characteristics of your application based on, let's say, this service is down. It's not optimal, but then you can actually say that, okay, right now this particular service is down, come back later, but I can serve you these kind of things instead of the whole service, the whole application itself is down. So this is an approach. But then containerization is a model of like how you implement this in a not in the code, but in the deployment phase. So this could be done even in a virtualized environment, but then containerization provides additional benefits around your application management. So how am I doing with time? Okay. So now let's.
Jay, I'd go for another 10 minutes or so, if that's good.
Yeah, it's good. I think I will rush through. I mean, sorry, we lost some time, but I think I can make.
Yeah. It's all good, but it's good content. Absolutely.
All right, cool. So let's say what other benefits are there when you move from on-premises to cloud? There are a bunch of things, right? When you are on-premises, you pretty much have to do your hardening of the application, your security, your poster of security poster, your your governance, your compliance, and your networking. All sorts of things come into play. But when you move all these things to cloud, there are already pre-built solutions for all these things. And the other part of that is cloud is ever evolving and changing, and it adopts all these standards for you. And you will be worried that your on-premises may not have the scale and the capacity or the skill set sometimes to cope up with all these ever-changing compliance and requirements like that. So cloud is a service, which means that there are people really working for this, and then that's their business, and they have to take care of that for their customers. So when you move to cloud, then you get all sorts of benefits like software-defined networking. You have caching solutions. You have artificial intelligence solutions. You pretty much use the libraries of all that. If you are trying to do this on premises, you probably, if you wanted to have a rich reporting and analytical tool, then you are going to write all those things by yourself. You're not having the APIs for those. And when I say that refactoring versus rewriting, those kind of decisions are coming into play. You're going to take some of those solutions that is available in the cloud and fit it into your solution, into your actually problem, into your solution process. So that actually provides you additional benefits. And lift and shift doesn't provide you all that. You have still the same code, but it's running somewhere else. So that's kind of the modernization aspect of cloud migration. So now I will a little bit talk about containers. I think someone else is going to talk about Kubernetes and containers, but I just wanted to give you guys a brief overview of what application modernization means, and then I'm going to talk about a little bit containers and what that means, and how Azure provides containerized solutions. So let's talk about what is a container. So when you are like, initially we had physical machines, and everybody for one application, you have one physical server. And then, we found that, okay, that's a waste of my resources. I have a big machine and it's only running on application, or maybe running 2 applications. Now I can give this server to multiple people, and then they can use it as it's their own server. So we came up with the virtualization solution. So you have the hardware, and then the hardware actually has an OS. That's your initial physical hardware. But now we have a virtualization layer on top of that, and you put different VMs on top of that. That's the virtualization. And the containerization is going one step further. Even a virtual machine is given to one set of users, and then you can have a single application probably on that. But containerization is independent of the virtual machine itself, or even the OS. So you have a specific container that is running in the virtual machine, or even physical machine. That is a full-blown application container space. So you have the libraries, you have the binaries, everything in that, and it is not dependent on anything else. And that container can be plugged into any other machine itself, wherever the container engine is there. So that means that you have better agility and then portability. You can take one containerized application from one machine and somewhere else, and it also densely packs your application. So you get more density out of what you have. And then it's a rapid scale. So you are scaling these containers irrespective of the machine or anything like that. If the machine has space, you can scale the containers within that machine and things like that. So it actually effectively utilizes your environment much better than even virtualization. So with that, let me just move to the next slide here. So this is the main differences between virtualization and containerization. So in the virtualization process, there are 2 types of virtualization. One is called type 1 virtualization and the type 2. In the type 1, underlying the hardware, you run something called a hypervisor. And then that actually orchestrates the VMs for you. Hypervisor is a layer that creates the VMs on that hardware. And then you can create multiple VMs on that physical host. But in the type 2, it's just like another machine. You're running a host OS, maybe Windows or Linux or whatever it is, and you run the hypervisor as an application on top of that. And then you still use the virtualization. It's much more, it is a little more indirect way, but it, the type 1 is the best way to do to optimize your resources. And containerization is actually, again, you run a Docker engine, which is providing you containers on top of the VMs. And then you essentially abstracts everything off of the VMs, or you don't even care about the OS. You have the containers where you have the application running. And that's where a container is launched by running an image. So you have an application image, which is a binary, and then you pull that image and then run a container off of that. So it is a full-fledged, self-sustainable entity, and then you don't have to really care about anything else, and it can run anywhere. And a Docker is the main engine that runs containers. There are some other things, but it is actually the primary container tool that people use. All right, so what are the challenges with the containers and why do we need Kubernetes? So that's the next thing I will talk about. So in the talking about a machine, you have a file server, you have a domain controller server, you have a database server, you know what it is and then what it is meant for, and you go and take care of those things. But containers are everywhere, right? So it can be run in a machine A, machine B, machine C, all kinds of things. And then if you are clustering containers for high availability, an application can be talking to different containers, or the same application can have multiple containers running for load balancing and all that. So things can get messy, and we don't know where these containers are running. How do you find it? And who is managing all these things? You know, a single person can go delete one container and then just set up anything. That's where the challenge comes, and we need somebody to manage all these things. That is called Kubernetes. So let's talk about what that means. So we need a cluster management, a scheduler when the life cycle of the container, when it comes up, when it dies, and then how to discover a container. When application needs to run something, it has to discover a container from a bunch of containers sitting else in all over the place, and then load balance containers. All these things has to be done. That's called an orchestration. That's where the Kubernetes comes into picture. So Kubernetes is a Greek word, and it's an open source software for automating deployment, scaling, and management of containerized application. So you only manage, you only talk to Kubernetes, and it takes care of all the deployment, lifecycle, scaling, load balancing, and discovery, all kinds of things under that. So you have a single tool that you operate with. So, and again, it means helpsman or pilot, and it actually, and I think the word governor also, gubernatorial is the adjective for governor, so that also comes from Kubernetes, I feel. Those are some of those concepts. Now, Kubernetes is pretty simple. Like basically, you have a master node, which actually is the main brain behind that, and then you have worker nodes. So the containers are deployed into the workers, and then a bunch of containers come under a pod, and then there is a kubelet, which is actually what your command line syntax goes to kubelet. You translate into the node and then runs those things there. And then the kube proxy, which actually allows you to interact, provide an IP address for any of those containers running within that. And then the master is the one that actually ties all these things together. So this is you can do this on premises also, right? Kubernetes doesn't need cloud or anything. It's a standard deployment model. Basically, you create the master node, you create worker nodes, and then all those things are tied together. There is documentation how to do that, all that. So when you're doing that, you will have to do several steps to do the Kubernetes in the hard way. So installing client tools, and there is a bunch of stuff. It's in the Git if you want to look at it. But pretty much you will have to manage all these things. Once set up, you can actually use Kubernetes to deploy your applications into the workers, and then you can use those applications. And now, as like anything else, Azure provides a platform service called Azure Kubernetes Service. So what that means is you don't really, the previous slide you saw a bunch of steps where we are actually building the Kubernetes environment with hand. You don't have to do that. Pretty much you orchestrate, you just bring up an Azure Kubernetes service, which is a service that Azure provides, and then the master node is encapsulated off of you. And then it actually creates the worker nodes behind that, and then you get everything, your control console and everything you get, where you can use your commands and everything. But with the one click of a button, you will be able to build a Kubernetes cluster in Azure. So this is again, when you're modernizing your applications, you can create a AKS service, and then you don't have to build and then keep these your own Kubernetes cluster. You can even go into Azure and then take a bunch of VMs and create this Kubernetes cluster for you. But this is much better. Then you don't really need to worry about the master node or anything. You just say that how many clusters I need and some parameters, and then it creates all this for you. So that's pretty much it. Now, what also comes along with that is you will be able to ship your, so once you have decided that you're containerizing your applications, you define your containers, you wanted to deploy it into Azure. So you just create this AKS cluster, and then you take your application and put it into that AKS cluster. That's how you can ship it faster. And then it is extensible. So all these things come with CI/CD processes and other extensible components. There are a bunch of those we can find in the documentation. And these are all, it comes with everything that you will have in Kubernetes. So, you could, and the other thing with the cloud, as I mentioned before, is we have a whole variety of management tools, including monitoring, log analytics, which is like collecting all the logs off of all these things. Every Azure resource emits telemetry, and that will be collected, and we can see all of them in log analytics. And we can also see how much container is utilized, what is the CPU utilization of all these things in Azure Monitor and all that. So if you are doing a container on your own, or like a Kubernetes cluster on your own, you will not be able to see all that. When you are doing it in the past model, Azure is aware of that model, and then it actually tailors its monitoring and deployment or logging and everything, and gives you the right dashboard and perspective to look at it. So that's all the benefits of using a PaaS model. And again, I'm just taking this Kubernetes and container as an example. We could talk hours around other deployment models and how we can create solutions in different ways. Okay, so
Jay?
yes.
If you could summarize, because I know I wanted to give a little more time, but I want to keep things moving along, that would be appreciated.
Yeah, I'm almost there. So then this is again, I'm just not again the DIY Kubernetes, and then your managed Kubernetes. What are the benefits? I think same as what I explained before. And this is the recap of evolve by migration. So once you migrate into Azure or any cloud, I mean, I'm not saying just because when we move to cloud, we get all these different add-ons, including backup and recovery, and then reduced operations benefit, costs, and then security compliance, because those are our foundational to cloud. So when you move an application without all these peripheral controls around that, you can actually take and put it into the cloud, and then you will get everything surrounding that. That's kind of the benefit, in addition to your better managed application and better architected application. Those are the things that you could do independently, but then you will get add-ons around the management aspects as well. So that pretty much covers my last slide, and hopefully I'm on time.